Um, so far we learned about. So far we learned about writing functions with writing functions. We learn about data types. We learn about the how the how the information flows through. So we learn about branching. So we learn about uh, the loops, branching, data types, and so far we know very elementary data types. Those are integers, doubles, float, right? Characters, bool. So now we have a little more complex data type, which is pointers and arrays. Pointers and addresses and arrays will be. Okay, so when we declare a variable, the variable is stored in the memory, right? So every variable has its memory, right? So if we have an integer variable, it will be stored somewhere in the memory, right? If you have a double, it will be stored in the double memory. And we also know one thing that what we know is that so what we know that integer is 4 byte, right? And the smallest unit is its bit, but then we talk about bytes. So the smallest unit is bit, but we always talk about chunks of bytes, right? We always have a whole number of bytes when we speak. We always have a whole number of megabytes, right? We always have a whole number of megabyte. So smallest unit is bit, and then we have a byte, right? And we know that integer has, so if we have an integer, we know that integer has a 4 byte, right? So 1, 2, 3, 4, and each has a 8 bits, right? That you know. Sorry, each has a, so this is 4 bytes, right? Right. So when you declare this variable integer a, so what it does is that it will find a memory address for you for the variable a, right? So this is, let's say this is your big memory, right? Your memory of RAM, right? This is your big memory, right? It's huge, right? It has a few gigs of memory. And you know this stuff is already been taken by your operating system. This is taken by your Outlook, right? So it's not that whole RAM is for your C code, right? This is for your Outlook, right? Then maybe this place is free, right? And in this place, and this memory is in this place, your code will be run. And this is a very big chunk of memory. This is not a very small, it's very big chunk of memory. So whenever you do int a or whenever it will allocate somewhere you some memory. Maybe like somewhere here you have this address where this a will store. So let's say this is the place where a will be stored, right? So what is the place name? So the place name we can get through %a. So this place where this a is stored, we can get through %a. So this will print us the memory address of a. Let me show you. So what I'm saying is that, so we have int a, and if you wanted to print the memory address of a, we can we can do print, okay, and to print the memory address we have to use a different data type, which is %p, right? /n, and we do %a. This will print the memory address of a. Now the question comes, right now a don't have any value, so do it has a memory address? Yes. So as soon as you declare a variable or a function, the system give you a memory, right? So it will have a memory address. Will it have some value? Will A have, first let's see the address of A. So this is the address of A. If I run again, do it has the same memory address or different? It will be different, right? Because your operating system dynamics all the time changing. All the time your memory is shrinking, expanding, new things coming, old things going out. So you might not get the same memory address, but it will get a memory address whenever you, every time you run it, it will have a memory address. By out of luck, you are getting a address which is same, right? So every time you run it, you will get a different, you might get a different memory address, right? Now the thing is that will this have a value? So if we print the value of this, because we haven't assigned any value to it. So if I print the value of it, if I do %d and if I do this run again, it will give us something which is like it can give any number, anything to it, right? Which is kind of like any garbage value, right? So what will happen now? If we have now we introduce the concept of the pointer, right? So if you have a pointer p, right? So this is a different data type, because a is a variable which can only take the values of the integers, right? The whole numbers, right? Now we want to have some data type which can take the value of some memory address, right? So this is, now with this way we initialize a variable which has a capacity to store the memory address. So now we have to give it the value. So I'll initialize with the address of A, right? So I initialize it, and now I can, and also let's give some value to A. Let's say A is the 10, right? Now if I print the value of A, and if I print the address of A, so I can either print like the old way which I just show you, or I can print the P, right? Or I can, just to be validate, I can also print %A, right? And here I put the P, right? So let's see. So we have a value of A which is 10, right? Then we getting a address of A which is this hexadecimal number, right? And then we get a memory address of again the A. So this is, so the whole idea right now we just learned that it's possible to have a data type which can store the memory address, right? So this we can do it. Now how we can use it? So now let me show you, so we will learn the benefit of it, right? So we will learn in the going forward, like what's the benefit of it, right? How we can use the pointers, right? So every type we can get a pointers, right? So if you have all the types we have so right now we did for the integer, we can do the same for the double, we can do the same for the float, and we can do the same for the character, right? And the and we will have the memory address, right? So every data type that we learned so far will have a memory address, right? Obviously everyone will be lives somewhere, right? Now with this I will introduce this arrays, right? So now we have a single integers. Now if so going forward we will be, if we have to have a if you have a vector to store, right? So we need to have a array to store that. So if you have some vector v and which has let's say 3 elements, right? So we can do through arrays, right? So we will store all 3 elements like this. Now we can use pointers to access each elements of these vectors, right? So here we get to understand the pointer arithmetics, right? So we declare a pointer p and we initialize this. So we declare a pointer p and we initialize with the address of v. So we can do, we can do like this, because we array without the the square brackets contains the address, or we can do the this way. So both are syntax, since both are okay. So we can do this. So this both way you are pointing the pointer to the starting of the array, right? So if you do this, it will point to the v. If you do this, also it will point to the starting of the array. Now let me do a little bit of arithmetic. Yeah, sure.
Okay, guys, just so you know, I'm here just to evaluate the cheat performance. Even when asked you, we do this kind of thing. But, older, I'm sorry to say that I'm older. Employees need to come to the class and essentially observe how the cheat is performed. Okay, have a good one.
Okay. Thank you. So we have this. So we have this. We can initialize v either. We can initialize p either through this or through this. Okay. Now. So now let's print. So using p, now we can access all elements of v. How we can do that? So we can print the value of v0, right? And we can print the value of %d/n star p, right? So we're going to get the same answer, right? Or okay, I haven't introduced the concept of the star p. So maybe let's first do this thing. So let's first print the address, right? So we are printing the address of v0 or p, should be the same, or v also. All three are the same thing, right? Are you with me? So all three are the same thing, right? We can print the address of the starting element, either v0, and then putting this symbol, and this symbol is famous to, this symbol has the only one job, to get the address. So if you do put this symbol on front of this, it will give you the address of this. If you print the p, it will also give you the address. Obviously I need to change to the format specifier, which is %p. And if you do the p, it will also give you the address, and if you do the v, it will also give you the address, because you initialize with this. So let me show you. V, it should be big V, right? So yeah. So let me. So you see that all three are the same, right? So just I wanted to show in this part. I just wanted to show you that it's possible to. So it's possible to access. It's possible to access the array using a pointer. Now what I will do, I will now use the pointer arithmetic. So what will happen if I do p equal to p plus 1? So I increase p by 1. What is p? P is the memory address, right? So what is, so there is 2 apples. What is if I increase the apple by 1? It will become 3 apple. What if I increase apple one by apple, it will 4 apple. So anything which has unit, like which is similar, if I increase by 1, it will go to the next thing. So this pointer is, what is the pointer? Is the pointer pointing to the memory address of the integer. If I increase by 1, it will go to the next one. So if I increase this one by this by 1, if I print p, what I will get? I will get something this plus 4, right? So let me now remove other things. So now I wanted to show you that it's very important to understand. So if I increase this, you see, I will get something plus 4. Because for pointer, integer is a 1 unit. Integer memory is a 1 unit. It's like there is a block, and each block has a 3-bedroom house, right? So the apartment number 100, right, and apartment number 101 will be three rooms away, right? There will be three units. Or there is a block which has 2 apartments. There is a block which has 2-room apartments. So if you increase by 1, you will move to the new apartment which has two rooms. Right? So the same thing. Memory, the way memory is a block of, apartments, and if you have a array of doubles, so each apartment has 8 rooms. If you have an array of integer, each apartment has 4 rooms. If you doing character, each apartment has a single room, right? And if you are increasing, you are moving to the next apartment, and you are moving to the next apartment. If you are decreasing, you are coming back to the next apartment, right? And everything has an address, right? Every apartment has an address, and every apartment has a value, like who lives there. So there is an address and there is a value, right? So every apartment has an address, right? Like 100, 101. But every apartment has a different value. In every apartment, there different person lives. So similarly here. Okay, so this how the if you do plus minus 1, you will go one step back. Okay, so this is this way, this is this. So we learn about the arithmetics of it. We can also get the size of each variable. So we can get the size of what is this size of p. So how many bytes p is taking? You remember this function? Right? So we can get the size of each pointers through using size of function, right? So this is this thing. Yeah. Now remember when we used to do the scanf, we used to do the ampersand, right? So now we know that. So when you used to go the scanf, so when we used to do scanf, we used to give a ampersand of the variable. So what is happening? It's scanning the value and putting the value to the address of this. So that's why we used to have the scanf, right? And if it's right. So now the values, so we can retrieve the value at the memory address using this, right? Now, so using p we can get the address. If we have to get the value at this address, how to do that? We have to do star. So if you do, so two things are very easy to remember. I think this is like little complex, but two things you can write in your paper, which is always like easy. If you put if you put this symbol, you will get an address of this variable. If you put this symbol asterisk, if you put ampersand, it will give you address. If you put the asterisk, it will give you the value at that address. So somehow you get the address of the memory somehow, and if you put the asterisk, it will give you the value at this address, right? And if you put the ampersand, it will give you the memory address of this variable, right? So now, but can I do this on A? Have a look. Can I do this on A? No. Can I do this? Sorry, let me first do D. Now answer this question, right? Can I do this line? No, because it should, this asterisk operator should need a memory address. It work. What is the A? A is just value 10. 10 is not any memory. Memories are always in the hexadecimal number, right? So I cannot do that, right? I can do this. So first I get the address of A, then on the address I apply asterisk, right? Now it's possible, right? Makes sense, yeah? So this is doable, this. So now I wanted to get the access these all three values using the pointer P, right? So what I did, I initialized P with the V, right? And then I can now let me remove everything. Now I can just simply print. I can simply print for value, because it's an integer, right? So %d/n, and then I can do *p, right? I mean, we'll be using this concept a lot, right? So I can do *p. So this will give you the value of the starting element, right? V, right? So it will give me 1. So it will give me 1, right? Because P is pointing to the first value. Or I can do, if this looks like little clumsy, you can do this same thing using this, as I told you. You can point like this. You can do this, right? Same thing. So if we don't assign any index, it will point to the first index, right? So now if I do P is equal to P plus 1, and if I print again the value at this P, what I will get? Now I increase the pointer by 1. And if I do this, what I will get? I will get 2. Because I increase the memory. Now I increase the apartment from 100 to 101. I said the apartment, first I pointed my address to the apartment number 0, and then I say give me the value, the person who lives there, so it give me 1. Now I pointed to the next apartment, so the next apartment address, right, which is 01. So in the next apartment who lives, person number 2, so I will get 2, right? Now what is the benefit of doing this? Imagine you have a very big array of thousands of elements or millions of elements. You can access all the elements, right? If you have a 1 million elements or 1,000 millions of elements and you wanted to access any element, you just pass the address, starting address, and so imagine if I have a very big array. So imagine I have a very big array, right, of 10,000 elements. To able to modify, to able to get the value, all I have to do is I have to give a starting address. So starting address, and how many places it's in the memory, maybe less 10, 20, whatever. And I will able to access that particular element. So I will show you how. Now I will create a array, right? Let's say let me create an array of 100 elements, right? Int v100, right? And let me give some values. Let's say it's contain the square root of, so it contains the square root of indices. So vi equal to I times I, right? So I can show you what it looks like. So it looks like this, right? It's just square, right? So now I wanted to work on the function. Remember the functions, local, global variables, right? Now I have a function void. Look, guys, this is very kind of. So now this function which find the maximum of the array, right? Now, because I have such a big array, if I create another array in this, if I pass a copy of it, it's a big overload to my function. Remember local global variable, right? So if I pass a local variable, right, the function will create its own copy. So it's a big load on the memory, right? There is already very big vector, right, vector v, and function is creating a copy of it. So 2 times your system is occupying the same thing 2 times. Not a good idea. What you can do, you can send the pointer, you can send the memory address of this 100 elements. So where these 100 elements are living, you can send the address of it, and the address is the reality, right? It never changes. As long as your function is running, you will have only one address. So you can send the address of this array, and then you can do anything. You can edit the arrays, you can print the arrays, you can do anything. You can modify whatever, right? So you are working on the same thing. Also, if you have a multiple function, all functions are using the same array. All functions are using the same data, right? So let's say you have a array of bank accounts, right? Balance. So couple of employees all are working on the same. Like one person A go to the branch 1 and he deposits the 1000 zloty in his account. So all branch should see it, right? It means all branch should work on the same or should have access to the same memory, right? When you go to a bank, you deposit some money, immediately is accessible on all the devices. You check on your phone, you go and check in a different branch, it will represent the changed balance that you have in the account. Why? Because all are working on the same memory address. It's not a local variable. What the bank would do, and it would be a disaster, it will create a copy of this bank balance and it will modify locally, and in the locally it will show that you have increased your memory, your money is increased, but on globally it's still the same, it's the previous value. So it will be disaster, right? So that's why memory addresses are like, working pointers are so robust, because you always get, if you work on the pointers, you always get the latest value, right? Because memory, there is only one memory where everything happening, right? So now I want you to send this big array to this function. So what I can do, I can send this address of this, right? First let, and also I should send the size of it, right? So what I can do, I just create a logic of finding the maximum. So what I'm saying, that if so this is a little logic how to find the maximum in the array, right? So this logic is like that: you assign some maximum by yourself, right? You assign some maximum value by yourself, which is 0, or could be anything, and you compare this maximum to the new maximum. So if the new maximum is bigger than this, you will change your maximum. This is the logic how to find a maximum in the array. It's this algorithm, and it's, you can, so if you have a sequence, right? Like say, if it's like you are a sequence of people and you have some money, and I say that like the maximum money, I don't know who has the maximum money right now, and I have to create a logic. So what I'm saying, that the maximum money is minus 1000 zloty, and I asked this lady that what's your money you have. She said 10 zloty. So I change my maximum, so my maximum become 10 zloty. Then I asked her again, how much money you have, and she said 1 zloty, which is not 10. So I keep my maximum 10 only. Then I ask you, how much money you have? You say 100 zloty. So my maximum now changed to 100. So that's way you can find out the maximum, right? So that's the logic you use in a sequence to find the maximum, right? So this is what I did, right? And the other thing that I'm doing, that I'm accessing, I'm just passing only single thing. The overload on the function, the whole thing that to appreciate here is this thing, that I'm just passing a single thing, not a big array, right? This function communication is not so heavy. It's a very lightweight communication. I'm not passing such a big information of 100, because I could have this array of so big, like 1 million, right? So I don't have to pass such a big information to the function. It's a very heavy communication, right? All I'm passing a single thing, my starting point, starting address of this array. So all I'm passing, that in group of flats, I'm just pass the starting address of these flats, and then I'm passing total number of flats. So with this way I can access all these things, right? Because I have the address of the because I have the address of the first flat. So the next flat will be +1. Next flat will be +1, and next flat will be +1. So it makes the communication so easy, right? So when I'm working on the big arrays, big data, it's easy, right? It's not so much of overload. And same thing I can do in 2D arrays, 3D arrays, whatever. All I have to pass is the starting point, starting address, and then the size of the blocks, memory blocks. So if I do that, so now at the end of this thing, I can do printf. And let me use this function here. Okay, so I do maximum, like find max, maybe little decrease the size. So find max in the array. I pass v, so starting address which is v, and then number of element is 100. Okay. You see? So I managed to find the maximum which is 9801, right? So the communication was very light, right? It's not. What is the naive way? This is the naive way. I'm passing such big arrays to the function, right? And then function is creating, this is not a problem. Function is creating its own copy, right? Local global variable, you remember? So if I pass this such a big array, the function will create its own copy and then work on the copy. So I achieve nothing. I mean, this is terrible idea, right? So you are working on a bank accounts of the people. So I give you a database. You created a copy of database, and you change something. You change something very important, which is essential, and then delete it. So it's a very terrible idea, right? Working with the local variables, because that's what local variable do. So the best way is that this is the database, everyone work on the same database, right? Access the same memory and stuff. So that's the whole idea with the pointers, right? This, this symbol, because the whole amazing thing about pointer is that it's give you ability to access something at the memory address, and memory address is the real physical thing, right? Your program, the only physical thing of your program is the memory, right? So the only existence of all this coding is the rest are all virtual, right? The only so, and that's for sure, right? So if you have something on the memory, it will be there. So that's why it's very robust to work on the memories, right? So you can have a pointer to the functions also. You can have a pointer, if you know C++, you can have pointer to the classes, objects and anything. So you can pass your function also as a pointer, because everything has address. Your function has to have a memory address, right? But here we learn about how to pass data types through pointers. So we can communicate between functions using pointers. Because previously we were doing through global variable, and global variable has they create a lot of bugs in the system, right? Because if you create a global variable, by mistake, if you create a global variable, let's say name A, you cannot use this name anywhere in the function. If you have a 1000 line of code or 2000 3000 line of code, by mistake you use the same name, you will have error. If your compiler ignore the error, it will give you so weird answers that you will be like, you will not able to understand why your value is changing and why it's not changing. So global variable is mostly discouraged. Use of global is mostly discouraged until unless you are using something which is forever constant, right? The best idea is to, if you want to communicate something, the best idea is to use pointers. And using pointers you can do heavy lifting, right? You have a millions of data type, you have a how big data type could be, you can communicate to them, change to edit to them, right? Imagine you have to only change a single value in a big array. A single value you have to change. You have to find a, imagine the task of the function is to find the maximum. That's it, or change the maximum, or change some single element. For that you have to, if you do the old way, like the local variable way, you pass such a big memory of the arrays, then you find the element, then you change it. Rather than create a pointer, right, which you point to the starting address, and then do a simple arithmetic, which is which index of the element you want to access, just directly access that, change it, and that's it. So it's so efficient way. You can have a pointer to pointer as well, right? So you can have a pointer and you can have a pointer to pointer as well, right? I will explain in the next class much more but it's so what we see that if you have chunks of data type, we can access through a pointer. Imagine each, so we have a chunk of data, array is a chunk of data, right? So array is a chunk of data, right? So this is it's a chunk of data. Right now it's integer, it could be float, and if you know C++, it could be images. It could be any data type. It could be videos, right? It could be video number 1, video number 2, video number 3. It could be images. So when we talk about abstract way, so data which is identical. So video 2, video 3, that would be also data type. Here we have integer, float, double, character, that's it. But we can have a much more complex data type, right? So let's say what we learned about arrays, that we can have a chunk of data type. So we have a chunk or a vector of data type, right? Let's say 10 or 20. So V1, V2, V3, V10, and which we are accessing through array. How about each element is also a chunk of different data? So this portion is a chunk of different, right? So it's like each block has apartment, or each block has so there is a society, there is a block. Each block has further many blocks, and then further, that's possible, right? So if this happens, then you need pointer to the pointer, right? So if possible, if you have that each of these has a different chunk, right? So we'll see in the next class. I will explain. So for example, 2D arrays, right? So the concept of 2D arrays, 2D vectors, right? So then we have a pointer to the pointer, right? So when we have a 2D arrays, we can think of each of these containing the number of columns. So this will be column number 1, column number 2. So this will be C1, C2, C3 and C10, and then C1 is also a chunk of column elements, right? So that we'll see. So we could also use, we will have also pointer to the pointer, and that we'll see to do the 2D arrays. This we understood already, right? Again, the thing to remember, if you put this ampersand, you get the address. If you put the asterisk, you get the value, right? The ampersand will take the memory. So the, how to the next page? Here. No. Maybe here. Yeah. So this is symbol is to get the value. It will give you the value. Okay. So maybe let's put like this. Maybe. So this operator, asterisk operator, it takes input and output. So output we always know that it will give you the value. Input, address. Right? This you make in your notebook. Like, because you will keep, it's little confusing because completely new, you can just make a small note on your notebook. And this operator, this operator will give you the address. So these two operators are completely opposite of each other. This operator will always give you the address. What it takes? Data type. Any data type. Or variable type. Or variable name. Maybe let's say the best name. So if you give any variable name, it will give you any variable name. It will give you the address. Right? So you give a name and it will give you the address. So yeah, so pointer is one of the little, like not very kind of easy concept. People keep forgetting and getting confused between things. So it's like, it's mostly in the interviews, it being asked, this concept is always being asked to check your knowledge. Pointers are the most pointer bothers the most programmers, right? So it's I hope you manage to understand maybe at least the basic of the things. So again, can be used to change the value pointed by the pointer. So you can change the value, because since you can access, you can also change the value of the address. So I haven't shown you this thing, I can show you now. So what is this saying is that so if I have a pointer which is pointing to the variable a, so if I do p equal to 20, so my value of a will be changed, right? It will be changed. Again, it's little confusing, right? It's taking time to process. Sorry. It's printing the address. This is the correct. Sorry. Let's first print the A. It's 20. You remember, now this is through pointer, but I will show you the same thing using two variables and you have to answer me one thing. So I don't remove it, I just keep it like this and I give you the alternate way. Imagine I have a variable b, right, 10. Then I have variable c which is equal to b. If I do, and everybody answer this question, if I do c equal to 20, what will the value of b? What will the value of b? Huh? 10. The value of b will be 20, like it will be 10, right? But with the pointer it's not like this, right? Same thing, we did same thing using pointer and same thing using normal variable. Right, we did the same thing using pointer, yeah? We changed the value at p by 20 and it changed. Because pointer changed the value at the address. And because it don't change, because it changed the value at the copy of this variable, not the exact value, not the exact variable. Right, this will be in the exam for sure, this concept. Yes. Okay. So that's the that this is also one of the you can one of the case for pointers. So I just show you this, so it can use to change the value, right? You can print the address using ampersand. You can print the address using p, or if you do this, you will get a different address, which is address where p lives, right? So this everybody understood? So what is the first printf will give? What is this line will give? So what is this? Let's say address of a. So this will give you the address of a. The next line. What the next line will give? Huh? The address of a still. Yeah, that's why I speak it. That's why it's not easy, right? If you speak it, then you get. I will correct you. Then you think again, and then it's get better, right? So it won't give you the value because it's p. P is address. If you put a star p, then it will give you the value. Remember this diagram? Let's do it again, maybe everyone. Yeah. Now, so what this will give me? Address of a. This part, what it takes, the variable name. It will take, that's why they make this block diagram. It will take the variable name and give the address. What this will give me? Address of a. But if I do star p, if I do star p, then it will give me the value of a, right? If I do this star p, then it will give me the value of a, right? Yes? Yeah, because to get the value, you have to give the address, but you have to attach the star. You have to attach the star, okay? And then this will give me the, what this will give me? This is interesting. This will give me the address of p, because p also lives somewhere. Because p also have some address. Okay. not a easy concept, yeah. That's why when I told you that this is, it takes time to process. So we can use to change the value pointed by the pointer, right? I just show you, right? So we can use the pointer to change the value. We can point, using pointer we can point to any variable, and then we can use the pointer to change those values. So it's doable, yeah. I just show you, yeah. Now here we have a is equal to 100, b is equal to 200, right? And then I created a pointer and I am pointing to a, right? Now what will this print? Everybody say it, it will be wrong only. I am not going to kind of, you can say it if whatever coming to your mind, right? So what this will print? What this will print? Maybe use this block again. Yeah, what this will print? Yes. This will print 100. Well, this will print what this will print? 20. Good. Because you change the value at the address. Now if I have one more this time, now if I this after this line, if I do this after this line, after this line, okay, maybe I'll just copy here. So we did so far maybe. Okay, so this we know, we did what it this will print 100, right? And this will print 20, right? Now if I put a print p, everybody now answer this. Now what will this will print? I think it's not a good idea. So what this will print? Hmm? 200. This will print 200. Right? It's like a little puzzle. I mean, I don't know. I mean, just so this will print 200 because now I changed the pointer where it's pointing. Now it's pointing to some different address. So initially it was pointing to the address of A. Now I changed to address of B. Now it's changing to it's pointing to a different address. So it's gonna print the value where it's pointing. It's pointing to the B. So it's gonna print the B. And okay, now interesting. Now what is the value of, okay, now answer this. This is interesting. Now what is the value of A and what is the value of B? So this we are okay, this will print 200. You can make a photo of it. Okay, now what is the value of A? The value of A is 20. Yes? Everybody? Yeah, and value of b, how much? 30. Yes? Yes? So that's how. Yeah, so this is the same idea that I explained. So ampersand a. Again we can do the same thing. Let's do this also. So by the way, it's being recorded. So if you're not making notes, but you hopefully you will. So what will this will print? Yeah, address. So it will print address of a. What this will print? Address of a. And this will, what this will print? Huh? Address of p. Yeah. Correct. Okay. Let's do this. So maybe I will just run it. Maybe before this one also I will just run you to show you what the error came. Yeah. There is semicolon. Now it should be okay. Yeah, address of a, address of a, address of p, which is different address. Okay. Now let's do this one. So this is a is equal to 10. So what this first one will print? So it will print address of a. And then this will print the address of a plus 4. So it will print address of a plus 4 because it's an integer, right? This will help you to solve many questions. Okay. So we can, I already talk about it, right? So you have a function, right? So when you have function, maybe let me explain again. So this is a function fun which takes integer value a and it modify a to 500, right? Okay, everybody answer this question, right? So what will the value of b if I print b, if I do print f? So what is the value of b? 500. Yes, how many says 500? No, it won't be 500. It's a local variable. A lives here, A take birth here and die here. There is no A after this. So A whatever, because you are not passing it. That's why we learning pointer, right? That's the issue with not issue, that's the characteristics of the local variable. They are designed to work only the local space inside the function. If you don't pass this information, the information just vanished. Because so when you pass function b, when you pass b to it, it creates its own copy of b. It don't work on the same copy. When you pass b, it will create its own copy. It will create its own copy of b, and it changed the value to 500, and then it disappeared. The b here remains like this. The b here it doesn't affect because it creates its own version of b. The function creates its own version. That's why we need to use the pointers. So I can show you. Yeah, still 20, yeah? But how about if I do this? I create a different function. Now I create a different function, and it takes the pointer memory address and change the value at the address. And this function 2, so let me call this function 2 now, fun2, and I pass the address of b, right? And then I print b. Now b would be 500. Yes? Make a photo. That's the doing the same thing using pointer. Right? The pointer totally changes this thing. Right? So the pointer totally changes the yeah. Yeah, so right, understood this part, right? It's a very important concept, yeah. So basically it working on the same b, right? Because you are passing the address, and that's being explained here. This is not b, this is b, this is not b, right? This some other b lives somewhere else. It works on some other place, and when the function finishes its scopes, it dies down. Just all this information. Once you turn off you're writing a Word document. Once you turn off, all information vanished. I'm creating this fancy graphics. Once I turn off, everything vanished. Same like here. Once the function finishes execution, everything wipe out. Nothing remains. Once your code finishes execution, everything wipe out. Now this is to show the second part that I show you. So you can pass through arguments the pointer. So you just pass the address. That's the way to pass the pointer to the function arguments. That's it. Shall we do the next part? Let me see what is in the lecture 7. Why it's behaving like this? Or maybe we can do some exercise. Let me see. There is no option to download. So this I also mostly explained, right? 2D arrays. Sorry, 1D array. Yeah, maybe let me show you, and this. Okay, how to let me? Why I cannot download it? Okay. Okay, so 1D array I was showing you, right? So create a 1D static arrays, how to array compare to the pointers, some consequence of pointer arithmetic, function passing array to the function, basic sorting algorithm, bubble sort, and generating random numbers, right? So we have this. So as I told you, like these arrays are like groups of chunks of data type, right? Or so here we have a chunk of integers, right? So this, how many chunk? There are three elements are there. So that's how. So you can have a chunks of images, chunks of videos, chunks of employees, accounts, balances, whatever, right? So it's not, if you have a bank account of 1 million employees, it's not a wise to write integer account number 1, integer account number 2, integer account number 3, and so on and so on. You have to write 1 million line of code just to create the account numbers variable. What you can do, int account number and then square bracket 1 million. So it will create chunk of data type of 1 million type. So that's the array, right? So what array needs? It needs a type, it needs a size, right? And it needs a name, right? So type, size, and a name, right? This is called a static array. Static array means when you know the size in the beginning. In the next there will be a dynamic array where you don't know the size. In the beginning you don't know how much big of chunk of array you have. Maybe 100, maybe 200. But here your chunk is fixed. 1000, 100, 100, 500, whatever. What happens if you use a very big chunk? For example, if you have what happens if you use a very big array? Let's say 2 million array, 2 million size, 3 million size. So your operating system will give you error, segmentation fault, because you can have as big array as your system can afford. If your system is small one, you don't have a 2 million array capacity, or 2 billion array capacity, right? So it will give you some error. It's called segmentation fault, right? And this, whenever it give you chunks of memory, it will give you continuous. It will always give you continuous. So if you ask, give me 20 apartments in a block, it will give you 20 apartments together, because otherwise your pointer arithmetic and logic don't work. If it give you two arrays here in the memory, two elements here, two elements somewhere else in the memory, what if you do pointer is equal to pointer plus 1 when you increase by pointer, right? You're not able to access the memory through access the array through pointer. So it will always give you together, continuous. So all the arrays will be continuous, so that you can use pointers to access them, to modify them, to print them, right? So this is not allowed, right? So you don't do this thing. When you create a array, just simply write here how many elements you wanted to create. Don't do this like n is equal to 8 and then create an array, because this also sometimes gives the error in the compiler, right? So once you create arrays, you can access them through 0, 1, 2, 3 variables like this, right? So when you create the arrays, you can access them. So the first element will have an index 0, and the last element will have an index n minus 1, right? So if you do, if for example you have an array of 3 elements, if you do the tab 3, it will give you error because don't exist, because it starts from 0 and finish at 2, n minus 1. So n is 3, so it will finish at 2. So if you do the 3, it will give you error. Now you can do the same thing through pointers, right? You can point your pointer to the starting of the array. The first will be the first address, or the first value at the address will be the tab 0, and if you increase the address by 1 and print the value, you will get the next index 1, and if you increase the pointer by 2, you get the next to next, right? So you are increasing the pointer by 1. Make sense? So P is the address of the apartments, right? So you are starting the address variable with the starting of the apartment, which is tab 0. You are saying that now increase the address of the apartment by 1. So you go to the next apartment, yeah? If you increase by 1 more, you go to the next part, or you just increase simply by 2, you go to directly to the 2 apartment. And that's how you pass array to the function, right? You pass the name of the array and the array size, right? So you pass the array name and then this empty square bracket and then name. This way you can pass between the functions. I can show you. So if you have an array, and which is, you can either initialize using this, or you can use a for loop to initialize them or access them or print them, right? Because it's a lot of manual work if the array is big. So you can use the for loop to print or access. Now I wanted to pass this array to a function. Void print array. So this function takes the array. So as I told you, to pass it, you have to have the, any name. It could be A, B, C, whatever, T. So you are telling to the function that the input would be a type of array, and then next element will be size, right? Size of array. So n, and then you do for int I equal to 0, I smaller than size, I plus plus, and if you do printf %d/n t0 ti, right? So that's how now you wanted to pass a array to the function for printing. So you do print array a and the size 4, right? That's how you pass the array to the function. Okay, this name should be main. There is no main. Right? So that's how you pass the array to the function. This will use a lot, you will use a lot in your CS2. Okay? So this is how you pass the arrays. And this random number, this is random number part. So if you wanted to generate a random number, you simply do this you have to include a library called hash include standard library dot h, and then you can, so to generate a random number you can use a function rand. So this will generate a random number, right? But every time you run it, it will generate the same random number every time you run it. So you can make it more complex, more like uh, more random by initializing this with time, right? So you have to include a library called time.h, and then you have to initialize with the time, and it will be more random, right? So you can do this part and include a time.h library. Now it's every time you will run it, it will generate a different random number, right? Because you initialize with the time, and time is all the time different. So okay, this we can cover in the next lesson. Any questions or anything? So we have this, we covered arrays, pointers for 1D. What we left for the next is algorithms. And what else? Yeah, 1D random number. This is examples, not the. Again 1D arrays. So now we are learn how to write to the file and stuff. So it's also, yeah, so we'll cover that. Again, you have to do the examples by yourself, as I told you many times. So open this file, do examples, right? Okay, answer this part. Let me copy. Why is not able to copy it? So what if maybe I'll do like this. So what this first line will print? It will print 3 and the address of A. And the next line will print 3 and address of A again. This one, so what the first line will print? 3 and 5, yeah? And the next line will print 3, 5 and the address of A. And the next line will print 3, 5 and the address of the B. And the address of B. Because now is pointing to the B. Sorry, value of B, sorry. So the second line will print 3, 5 and 3. Because P is pointing to the A. And the next line will print 3, 5 and the value of B. Because P is pointing to the B. Yeah, you have to do at home, really, this is very important. Any questions or something? Okay, let's call this for this today then.